Hey, what's up, weebs? Today we are going to talk about piecewise functions. So what you're going to learn is what the heck is a piecewise function, if only my pencil worked. You're going to be able to figure out what value of the graph we're talking about. This is a little tougher than reading graphs, so I won't insult your intelligence. Then we're also going to talk about what is the domain and the range of those piecewise graphs. And you did see a piecewise graph in the last video, but we'll spend the whole video today just talk about piecewise. That way we really hammer out all that weird stuff that you got questions about. All right, let's go. So we need to start with vocabulary because obviously I can't talk to you if you don't know the words I'm saying. So a piecewise function is just a function that's made of different equations. And you only use them in certain areas of the graph or the domain, right? So it's basically a graph made up of a bunch of different little graphs. Cool? The domain, again, this is just review, is all the x values where the graph exists, or it's all the x values you are allowed to plug in. You might want to write that down. Allowed to plug in. Cool? And then the range is all the possible y values that come out when we plug in those x values. Okay. The last thing we need to talk about is open and closed circles on graphs. We did see it a little bit in the last video, and I apologize for not going over the meaning then on its own vocabulary slide, but I mentioned it. So let's just kind of nail it down in case you did not really understand what I was talking about there. So on a graph, you're going to see sometimes you'll have an open circle. So actually, let me draw a little bit better graph than that, please. So if we have a graph, and let's say you have an open circle like that, that means that this point right here on the end is not included. It's like a hole in the graph. It's almost there, but when you get there, there's this big hole you step in, and you're like, well, who took my graph away? Okay. Likewise, closed circles, like that, means that they are included. So we do count that point on the end. Okay, cool. All right, let's look at a nice, beautiful piecewise example. This is actually one off your homework. Homework. That's not how you spell home. Sorry, hang on. I'm a math teacher. Well, Mr. Barton, math teachers can read and write too. Yeah, of course they can. Sure. Okay, so this is a homework example. So I'm going to tell you some answers from your homework. Write this stuff down. All right, so here's a graph from your homework. I've kind of taken the liberty of writing out the piecewise function. So that's what the function would actually look like if it were written out and you wanted to read it. It's a little convoluted. So let's break this thing down first. So this whole graph is f of x. It's just one function, but it's made of little equations. So what this says is f of x is equal to x squared, but this comma and thing here, this is telling you where to use x squared. So it's kind of telling you where this part is used. So when x is less than or equal to 1, so that means 1 or smaller, so 0, -1, -2, then we're going to graph x squared. Then you're going to say, but Mr. Barton, what if it's bigger than 1? I'm glad you asked, children. When it's bigger than 1, when x is greater than 1 and x is less than or equal to 2. So what this means is from 1 to 2, including the 2, because it's got the or equal to, but not including the 1. Then f of x just equals 3. And if you look over here, it's just a horizontal line lined up with 3. It equals 3 the whole time. It's always at a height of 3. Then our last little chunk just says f of x equals x when x is greater than 2. So after we pass 2, then it's f of x equals x. And that's the equation of that linear line. All right, so let's talk about the domain of this function. Then we'll talk about the range of the function, and then we'll talk about how do I read off values of the function. So domain, again, is your x-axis. So we want to know what values of x does this graph line up with. Well, we have an arrow on this left side, so this means this goes left plus up, because it's kind of pointed up to, forever. So left forever on the x-axis is forever means infinity, left means negative. So our graph goes to negative infinity. Then it keeps coming over here, keeps moving over till we get to 1, but we include 1. So our domain for this chunk right here is negative infinity to 1 inclusive. Okay, cool. Then this piece right here goes from 1 to 2, and it would just be this thing right here. So union 1 to 2. But you'll notice I include 1 here, but don't include 1 here. Right? And you're going to say, so is 1 included or not? Well, at 1, there is a point on the f of x function. So we just say 1 is defined here. It's not up here though. The point for 1 is down here because that's the filled in one. Then after this little flat part, we switch to the other function, but where this one ends, this one starts. So union from 2, and that just goes off forever to infinity. So it goes from negative infinity to 1, then 1 to 2. All right, well, that's really just one complete thing, right? There's no gaps in there. It goes up to 1, stops there, but immediately starts a new one. There's not a big gap here in the middle. So this doesn't even need the union. We could just write negative infinity to 2. But Mr. Barton, there's not a gap there either. I know, look. Ends at 2, starts at 2, then it keeps on to infinity. So there are no gaps anywhere. If I took this whole thing, I maybe took a line and then smushed the graph, it would look like that. It covers every single x value. So even though there are jumps, any x value has a y value associated with it. So we say our domain is all real numbers. Another way you could write this, and I don't really care which way you write it, you could write from negative infinity to infinity. This means all real numbers, but is obviously a little bit more writing than this. I will use them interchangeably throughout class. So if I write this, it means all real numbers. If I write this, it means all real numbers. Same idea. All right. Now let me clear all this stuff off so you can look at the range. All right. For range, remember we are talking about the y-axis. All right. So we want to know how far down does it go? Where's the bottom? And then how far up does it go? So the bottom of this graph, the lowest any of this stuff ever gets is right here, and it's at 0. So our range is going to start at 0. And you're going to say, Mr. Barton, does it include 0? I don't see a filled in dot there. There's not a big smudge there. If you have just a solid line, you get to assume that this is filled in. Lines are actually just filled in dots really close to each other. So when you fill them all in, you see how they just turn into one solid line? If this isn't included, what they'll do is they'll put a big open circle there and make it really obvious, hey, there's a hole here in your graph. So if you're looking at any solid part here, all of this is made of filled in dots. So yes, that is included in our graph. So our range, the lowest this thing ever gets is 0. And we're going to put a bracket there because we're including the 0. And then it goes up to infinity. But Mr. Barton, what about this gap right here? It doesn't really matter that there's not a point between 1 and 3 over here, because there's this whole section right here that fills it in. I don't care that there's not something here if it exists somewhere else. So it goes from 0 up to infinity, and that's our range. Now let me fill in our domain again. I accidentally erased it. There we go. All right. And now the last thing we need to talk about is what is f at 2? You're going to say, Mr. Barton, you taught me to read graphs already. I'm really good at it. I said it was super easy in chat the other day, made everyone else feel bad because I'm so much smarter than them. But this one can be a little tricky, so let's go over it. So f of 2, remember this 2 is telling us the x value. So let's go over to 2. We're talking right here. We want to know how high up is the graph. So there are 2 spots on our graph here. There's this filled in dot and this open dot. So where does the dot exist? Well, it exists at the one that is a dot, right? So when we have an open dot and a closed dot in the same spot, you will always want to take the closed dot because that's where the point exists. So we would say f of 2 is at 3. There we go. So there's domain, there's range, and looking at a couple of, or one value, not a couple, of this piecewise graph. That might be a little confusing, so luckily I have another example for you that does have some important gaps where we're going to have some weird domains and ranges. Okay, so let's go ahead and start with our domain. I think that's maybe the easier part of finding this. So domain, we want to know how far left and how far right does it go. Remember, this is the x-axis, this is the y-axis for range. So how far left do we go? Oh, well, there's an arrow here, so that means left forever. So it starts at negative infinity. Then our graph comes over until right here, this filled in dot, which means it is included. Our graph stops at negative 2. So our domain goes from negative infinity to negative 2, bracket, because it's filled in and we're including it. Now, unfortunately, from negative 2 all the way over to here at 0, there isn't any graph. There's not something up here. There's nothing down here. It's just a big gap in the graph between this absolute value looking function and this thing. So we don't get to include any of this stuff in the middle because there's nothing there for us to include. So we're going to just skip it. It doesn't exist. We can't include -1, -0.5, -1.5. None of that exists. So the next point we have a graph is here at 0, but it's an open circle, so it's not included. So we're going to put a union to connect them. We're going to put a parenthesis because it's not included because the circle is open. So it starts at 0 again and then continues on until arrow, it goes forever to positive infinity. Parenthesis because infinities always get parentheses. All right, now let's look at range. We want to know how far down does this graph go? Well, this looks like the lowest part here. This arrow means down forever, right? Forever. I should use proper English. Don't tell your English teachers. So it starts at negative infinity. It goes down forever. It gets to negative infinity, sort of, not really, but negative infinity. Okay. And then our graph continues up until right here. This is at -1. But again, this is not included because it's an open circle. So we say the -1, but we put a parenthesis to show we're not including the end. Then from -1 all the way up to 0, there's a big gap here in our graph. So nothing exists there, so you can't include it. So we're going to put a union to show that we're connecting two things that aren't continuous. And we're going to start wherever the graph starts up again, which is right here at 0. Mr. Barton, there's no dot there. Do we include the 0? Yes, of course, because anytime you have a solid line, you get to assume that it is included. So bracket 0 is where we start again. And now it goes up. And you're going to say, Barton, does it go up to 1 or does it go up to infinity? Well, it does go up to 1, but it also goes up to 2 and 3 and 4 and infinity. So we want to take the continuous side that keeps going up. So it's going to go up to infinity. There isn't really a way for us in the range to say, hey, one side stops at 1 and one side keeps going. It's maybe a limitation. It's not really what range is even asking. So don't worry about it. So here's our domain. It goes from negative infinity to -2, skips a big chunk, goes from 0 all the way over to infinity. For range, it comes from negative infinity way down over here, all the way up to -1, stops, skips a little bit, and then starts again at 0 and continues on up forever. Now we need to figure out what are the values for these points. Again, these numbers are our x values. So we're going to go horizontally on the x-axis until we get to this number, and then go up or down to see what part of the graph lines up with that. So if we go left to -4, this goes up to 1. If we go left to -3, that point's included, don't worry about it. That's a 0. If we go left to -1, okay, here's the issue, right? There's a big old gap here in our graph. There's nothing here. So don't put 0. 0 is a number. We need to say that it's not a number. It doesn't exist. So the way that we say that is we say undefined, right? Our graph doesn't have anything. It's not, there's no function for us to look at here. It's not defined, right? And then if we look at f of 0, here's 0. Oh, look, that's an open circle there. Do open circles count? No, absolutely not. They're holes in your graph. If you walk out into your street, right, and you're actually, this is a terrible example. I'll think of a better metaphor later. Don't worry. But because this is an open circle, this point doesn't exist. There's not a point there. So it would also be undefined. Defined. There we go. All right. That might have been a little bit confusing. I understand domain and range can be very challenging, especially with weird, chunky graphs that don't exist everywhere. So if you need help, luckily, the state of Arizona has saw fit to pay me almost no money at all to sit in a virtual meeting room and explain it to you until you understand it. Please take advantage of it. If not, I'm going to have to go watch YouTube videos, color, pick my nose. So, really, I'm relying on you to keep me from being some kind of degenerate. So go ahead and hop in WebEx. Ask me some questions if you're confused. You're probably confused, but let me know.